Welcome to Building Brightline West, the Geotechnical Investigations Edition. Throughout 2024, Brightline West has had engineering crews working along the route from Las Vegas to Rancho Cucamonga, investigating the geology of the soils that will support our tracks and facilities. The data collected from these investigations help finalize the project's designs as we ramp up to full-scale construction. Featured here are investigations on the site of our future vehicle maintenance facility in Sloan, Nevada, which is just south of Las Vegas. We'll have a more detailed look at the site and VMF in the coming months. Let's take a closer look at this process. The process starts by driving the drilling truck to the bore location that was identified during planning, and then setting up the truck. The first several feet of the bore are the most important in ensuring that it is going straight down, which maximizes the downward force from the truck, rather than fighting lateral movements. This makes drilling faster and more efficient. At this bore, the first several feet were through a soil called caliche, which is essentially a naturally formed cement formed from calcium carbonate and the sand and gravel in the area. Once the first section of the drill pipe has been used, It is removed since it has a special head to get the bore started, and a new section of pipe is used to lead the rest of the bore. Next, they begin installing a secondary pipe in the middle of the main drill pipe that is used to grab soil samples prior to the arrival of the drill. This smaller pipe is pounded into the ground using a second attachment on the truck. Once it has reached a specified depth, another section of the drill pipe is attached. Notice how much faster the boring is now that they have made it through the caliche. At intervals specified by the plan and overseen by the geologist on site, the tailings coming out of the boring are collected for evaluation. Now here's the crew pulling out that smaller pipe with the core. The sample is placed into a bag and tagged with location information and is logged by the geologist. The samples are then taken back to a lab for more detailed evaluation. The lab results, along with the geologist's notes from the field, are used by the geotechnical contractor to make recommendations for things like how the foundation should be formed and how the site should be graded. From this point forward, the process is repeated until the bore reaches its specified depth. Another form of geotechnical testing going on along the corridor is resistivity testing. With the trains for Brightline West being electrified, additional testing is required to determine how conductive the soil is. This influences the depth of the necessary grounding rods. While far less interesting visually compared to the boring, this testing involves placing 4 probes into the soil at equally spaced distances, and then wiring them to an earth ground resistance tester. This box injects a known electrical current into the outer 2 probes, then picking up the resulting drop in current by the middle 2 probes, therefore determining how well the soil is at conducting or resisting electrical currents. Stay tuned over the coming months for more videos on our route, facilities, and construction.